This is the video for section 6.1, part 1. There's going to be 2 parts to this section. And this first section is actually pretty easy. They're going to give us an equation, and we just have to determine whether the function is a solution to that differential equation. So here's example 1. It says determine whether the function is a solution to the differential equation y double prime minus y equals 0. So here's what they're wanting us to do. In part A, we have y equals sine x. So they want us to find the second derivative and then subtract our original equation y and see if we get 0. And if we get 0, then that function is a solution to this differential equation. So let's find y prime first. So the derivative of sine we know is cosine x. We need to find the second derivative, and the derivative of cosine is negative sine x. So now what I need to do, here's the equation that I'm supposed to see if this is a solution of. And now I'm going to substitute these values in, or these functions in. So y double prime, that's negative sine x, minus y, but we know that y is sine x, so minus sine x, and I'm supposed to get 0. Well, I don't. I have a negative sine x and a negative sine x. That's negative 2 sine x. And that does not equal 0. So this function is not a solution to that differential equation. Okay, so let's do part B. So y prime equals. This is the function just e to the negative x with the constant out in front. So I know I can keep that constant. The derivative of e to the u is e to the u times the derivative of u, so times negative 1. So I'm going to stick that negative out in front. So now I need to find the second derivative. So again, that constant will stay there. The derivative of e to the u is e to the u times the derivative of u. So now that's going to make that a positive 4e to the negative x. So now I'm going to substitute these values or these functions in to this differential equation. So y double prime is 4e to the negative x minus y, and we know that y is this, 4e to the negative x, and it's supposed to equal 0. And it does. So this would be yes. Okay, let's do another one. C e to the x. And again, I'm supposed to see if this is a solution to this differential equation. So C just stands for any constant. Okay, so that it is any number we want. All right. So, again, this is just e to the u. So I know that the derivative of some constant and e to the u is just that e to the u times the derivative of u, and that's just 1. So my second derivative, do you see it's going to be the exact same thing? So now when I plug those functions into my y double prime, this right here, that's c e to the x minus y, and my y is c e to the x. It does equal 0. So this is a solution to that differential equation. Okay. Example 2, same type of problem, but they've changed the differential equation. This time it's x times y prime minus 3y, and it's supposed to equal 0. Verify that y equals cx to the third is a solution, and then find the particular solution determined by the initial condition y equals 2 and x equals negative 3. So in class, we're going to talk more about what a particular solution means and what that looks like. And we're going to talk more about that when we talk about slope fields. So for right now, I just want you to get used to seeing if this, if our solution is the equation that they give us, if it's a solution to that differential equation. So here's what they wanted me to start off with. Here's my equation, and I'm supposed to find the derivative of this. Well, this is just the power rule. I'm going to bring my 3 down. This is like saying 2x to the third. 2 is my constant. What would I do? I would bring down my exponent and then divide, and subtract 1. Well, I'm going to bring down my exponent 3 times c and subtract 1 from my exponent. And this time I only need my first derivative. So I'm going to take what I have and plug it into this differential equation. So I have x, I don't know what x is, times y prime. Well, y prime is 3cx squared minus 3 times y, and y is this right here, cx cubed, and it's supposed to equal 0. Well, if I take x times this, I have 3cx squared, so I'm going to add my exponents. And do you see that I do have the exact same thing? So yes, this is a solution to this differential equation, and we knew it was supposed to because it says verify that it's a solution. So your verification is your work. And then it says find the particular solution determined by the initial condition y equals 2 and x equals negative 3. So if I have, here's the second part of this problem, I know that y equals cx cubed. Well, we know from past problems that when it says find the particular solution given this initial condition, they want us to solve for c. And our answer should always be y equals something, and we should be solving for c. So they gave us numbers to plug in for our x and for our y. So it says y is 2, and my x is negative 3. So I have 2 equals negative 3 to the third power, that's negative 27 times c. Divide by negative 27, and I get c is 2 over negative 27. But that's not my final answer. My final answer, it says find the particular solution. Remember what I just said? Our answer should always be y equals something. So y equals, okay, here's my y equals, but instead of c, I'm going to write what c is equal to. 2 over negative 27 x to the third. So this is the particular solution given that initial condition. And then this is my final answer. Okay, that is it.